All right, fantastic. I want to welcome everybody to this session of the arXiv Accessibility Forum on HTML papers at arXiv. We're going to take a peek under the hood with developers from Meta, from the NVDA screenreader, and from LaTeXML, and from arXiv. My name is Shamsi Bryn. I work at arXiv doing user experience. And before we dive into the session itself, I'm just going to share a couple of notes about how the session is going to go and our agenda and some of the accessibility accommodations. One thing that you might notice is that the chat is disabled, and that is because the chat is very noisy for screen readers, but the Q&A tab is enabled. So, and that doesn't have that same problem. So go ahead and use the Q&A tab as you're listening to the speakers, as you're hearing their presentations. If any questions come up for you, please go ahead and pop them into that Q&A tab. I also wanted to share that volunteers are taking notes in an open Google document, just as a place to kind of check where you are or catch up if you need to. And we're going to paste that link into the chat so you can access it. We're just going to use the chat a little bit here in the beginning to share a few links, and then it will be quiet for the rest of the event. Wanted to share that there is a discussion board on the web page for this session. That's a great place to have side conversations or keep conversations going. You can access that anytime during the session and afterwards. That will be there. And there's a link for that in the chat. Also wanted to share that we're going to be reviewing a technical demonstration video, and we're going to post that link into the chat as well. You might want to check that out as we have our breaks. We're going to have 3 sections, 2 breaks. That's a great time to kind of go through that technical demonstration video if you want to watch it ahead of time. We're also going to go through it during this session, and that just demonstrates the interactivity of a screen reader with a math formula. We're going to try to maintain some deliberate pacing, not have a fire hose of information, give us all time to absorb information and learn. And this is also very helpful when you have interpretation happening, as we do at all of these sessions. So without further ado, why don't we jump right into our introductions, and I can call on some folks. Mick, would you start us off?
Yeah, my name is Michael Curran, Mick Curran, and I am, well, the creator and a co-developer of the NVDA screen reading software. NVDA is software that allows blind and vision impaired people to independently access the Windows operating system, which is, greatly increasing education and employment for blind and vision impaired people around the world. And NVDA is both free and open source. So I've been working in software accessibility for around about 18 years or so, both on the NVDA project, but also consulting on the accessibility for other many companies, Google, Adobe, Mozilla, Yahoo, IBM, Microsoft, many companies. And I've had lots of wonderful experiences and have learned a great deal over the years, and hopefully imparted some knowledge too in terms of how best we can make software accessible to those who have disabilities, in particular those who are blind and vision impaired. I should point out that I'm also totally blind myself, so I have obviously lived experience in this area as well.
Thanks, Mick. Deyan, would you go next?
Hi, everyone. My name is Deyan Ginev. I am a co-developer of LaTeXML, and in the last 6 years, I was part of the LaTeXML team with Bruce Miller at the National Institute of Standards and Technology. We started working with arXiv documents 15 years ago and converting them to HTML. We always wanted to make arXiv machine readable for a variety of really cool applications, math search, artificial intelligence, and nowadays accessibility. And it is really rewarding to see LaTeXML used by arXiv. Nowadays, it is also, as Mick pointed out, an open source software. We are a universe of open source tools represented here. And it is my pleasure.
Thanks, Deyan. Yeah, thank you for reminding us that this is also a mini celebration of open source software. Tony.
Hello, my name is Tony Malykh. I am a software developer at Meta, and I am also blind. Occasionally, I'm also a contributor to NVDA screenreader that Mick has worked on when I have time, which doesn't happen often these days. I am also a software engineer in machine learning. So as a part of my job, I need to read machine learning papers just to stay up to date on current research. So that's why I guess I feel the pain of not accessible papers, like the way it used to be. The papers weren't accessible, so I'd be happy to share my experience about how I deal with non-accessible papers and how our arXiv is helping with this problem.
Thanks, Tony. Norbert.
Hello, everyone. I'm Norbert Preining. I'm a core developer of TechLive since about 20, I don't count, years at least. So Tech and LaTeX is the basic language we use at arXiv for the papers and which is used by LaTeXML to convert. Yeah, so I'm very happy to be here on the board and the discussion and see how accessibility gets improved over time for everyone's better usage. Thanks.
Thanks, Norbert. So we wanted to start out with Mick sharing some information about accessibility to just kind of help ground us in why this conversation is important.
Yeah, thank you. So I guess, look, at a really fundamental level, people have different, all different abilities and ways of working. We all do. And in some ways, we all might have our own disabilities or abilities or whatever you want to call it. But different ways of learning, we might depend on some extra tools or something to be able to get the job done. I mean, even someone, many people might wear glasses, and obviously that's an assistive technology in itself. But there are many different, abilities and disabilities, and they can be, I guess, categorized into a few different broad categories, such as sensory, physical, and cognitive. And when I talk about physical, we're talking about dexterity. Perhaps you may have limited or no use of your hands, which might affect the ability to type on a physical keyboard, for instance. Or we're talking about sensory, so that will be, say, people with low vision or who are blind or partially deaf or totally deaf, and other things, sensory issues like that. But also, of course, cognitive in terms of things such as autism or neurodiversity, or ADHD, or anything that affects the ability to process information, whether it be too much information, too little information, or at different speeds, etc. As I said, people with disabilities often rely on tools or assistive technologies to help them access to information or interact with the world. For example, a blind person might use software known as a screenreader on their computer, tablet, or phone to help them access electronic information. And this kind of software allows them to be completely independent, like, being able to read emails or do their shopping or do their banking or run a business or whatever, because the screen reading software is essentially reading the text and other rich semantic information off the screen or out of the information, and presenting it either through synthetic speech or braille, etc. But then also for people with physical disabilities, maybe they're relying on, say, a pointing device or an on-screen keyboard. And then, of course, for, say, cognitive, we're talking about perhaps there are particular settings in the operating system or something that, limits the amount of fast-moving information or how often something refreshes, or helping them track words as they're reading along a line, for instance. But many of these tools, if not all of these tools, rely on rich semantic information in order to do their job. These tools can't just work with, say, an image of some text. It's not enough information. They really need the rich semantic information, such as, whether this text is a heading or, whether it's a list, or whether it's a table with how many rows and columns, or where the table headers, all that kind of information is. These assistive technologies and tools rely very heavily on getting, as I say, rich semantic information out of this information or out of these documents. And that's why it's important. So why does accessibility matter, though? Why should we care? Why should the scientific community care? Well, for starters, really at a fundamental level, it's a basic human right. It's enshrined in the UN Convention for the Rights of Persons with Disabilities, and many countries have ratified this. Many countries have laws around the fact that information and services should be accessible to everyone, no matter what their abilities are. But also everyone should be allowed and be able to make a contribution to society. I really strongly believe in that. Everyone does have a right, and if not almost a duty to, I think, to make their contribution to society, no matter what their abilities are. But sometimes we might need some extra tools to do that. So therefore, it's really, really important to make sure that information is accessible or can work with assistive technologies. In the field of science and tech research, much research may be about or affect people with disabilities. We might be talking about health research, or research that looks at how people learn, or whatever. Much of that research will directly affect people with disabilities. And people with disabilities have a right to be able to access and have input in to that research and information. And there are also many people with disabilities definitely working in the scientific and tech space. In fact, I'd say that, certainly talking specifically about blind and vision impaired, the tech space is a really good opportunity and quite a common workplace for people who are blind and vision impaired, or for other disabilities these days. You might know a colleague who has a disability, or it could be yourself in today or in a few years, who is going to rely on making the text slightly because your eyesight's getting a little bit worse, and or changing the contrast slightly. And a lot of these, even these basic kind of settings and tools, do rely or work best when there is rich semantic, when there is real rich semantic information available. People with disabilities also have very diverse lived experience, and I think that's really important, because it allows, they can be providing really cool out-of-the-box thinking in different ways, and it's really important that people with disabilities can be part of the conversation. Many and definitely changed the world for the better. I mean, for example, Louis Braille invented a writing system that completely revolutionized communication and access to information for blind people. And he himself was blind, of course, and took it upon himself to find a solution that worked for him and others. And there are similar examples, today as well in regards to technology. Practical benefits for everyone. I mean, sometimes the work you might put in to make your information accessible to those with disabilities has ongoing effects to you and the mainstream community at large as well, because accessible papers or papers that contain rich semantic information are easier to transform and index into transform into various other formats, or work on particular devices, or looking into the future, or today really, much easier for AI to process, of course, as well, or looking at, it's becoming more common to to access information via voice input, for instance. And it's, of course, much easier for software such as voice input to be able to exactly know where someone wants to get to in a document, etc., if there is rich semantic information. So really, in closing of this small, tiny argument, I think that the scientific and tech community does have a responsibility to make it work accessible to all, and we will go through, I guess, today of sort of some of the options on how this can be achieved. Science and accessibility fosters a more inclusive scientific and tech community, but also the next scientific or tech breakthrough could come from anyone, as long, even someone with a disability, of course, as long as they have a chance to be included. Yep.
Thank you so much, Mick.
No problem.
That was really beautifully put. Next, we're going to jump a little more deeply into why HTML was landed on as a solution at arXiv, and how this ties into the points you were just making, Mick. I think a lot of those points are going to be illustrated in the discussion we're about to have. And I just wanted to kick things off with a tiny bit of history of how arXiv ended up rolling out HTML. This is a good story. So I do UX at arXiv, user experience. So I interview a lot of people, try to figure out what are people's needs, and how does that tie into what arXiv is doing? How can we serve those needs better? And about 2 or 2.5 years ago, I started to do some research into accessibility at arXiv and how could we become more accessible. And so I was interviewing people. I had called up lots of scientists, tracked down scientists with different disabilities, and they very kindly agreed to meet with me. And I was asking them, how can we make our website better? Because that's what I thought the conversation was at the time. And the answer that I kept getting over and over again was, oh, we don't care about your website. That's fine. What can you do about the research that you host? That's what I care about. And we heard this over and over again from different scientists with disabilities, as well as researchers in the accessibility space. And we finally got the message. And the other great thing that came out of those interviews is that they not only told us what the problem was, they told us what the solution was too. They told us arXiv needs to roll out HTML versions of your papers. Skip remediating PDF, give us HTML. That is what we want. If you can do that, you'll have real impact. And so that's what arXiv did. And just this last December is when we started to roll out HTML versions of papers on arXiv. And we're just using this as one example of many, many, many layers of accessibility efforts around the world. But this is one example that we're going to dig into a little more deeply today that I think illustrates many of the points that you were making, Mick. And on that note, one of those researchers that we interviewed who told us exactly what to do was Tony, who's a panelist with us today. And Tony, I wanted to ask you to share from your perspective, why was that your advice, and why was it important that arXiv add HTML?
Yeah, so I can tell my experience with inaccessible PDF papers. So as I mentioned, I was a machine learning. I would consider myself to be a machine learning engineer rather than researcher, but I guess there is no strict difference between these two. But anyway, I needed to read PDFs of science papers, machine learning papers for work. And what I found is that it was extremely hard for me to do, because apparently when paper is saved in PDF format, the semantic information about formulas is lost. Some characters are lost in formulas, and then basically the information, like which part of the formula is the subscript, which part is superscript, this type of information is lost. So reading PDF as it is kind of a hopeless endeavor, because you just miss most of the information in formulas. Another solution was to do OCR of a paper, and there are tools that can do OCR, but the accuracy is not very high. So it's very frustrating to try to understand output of OCR if it's only 90% accurate. So yeah, I was pretty frustrated about that. And then at some point, I reached out to arXiv people, and I talked with Shamsi. Yeah, so I told her immediately that HTML accessibility is much better than PDF. And yeah, I thought that moving to HTML is a better solution than trying to fix PDF. With all my respect, I've heard there are some efforts to fix PDF, so I guess I shouldn't discourage people on working with that, because maybe PDF can be fixed too. But at this point, the shorter route would be indeed trying to switch to HTML as opposed to PDF. So yeah, that was my experience with inaccessible PDFs.
I have to unmute myself. Thank you, Tony. That was really helpful to hear. I wanted to turn to both Nick and Deyan next, and to talk a little bit more about HTML from both of your perspectives. Why is that the medium that matters for your tools and for your roles?
So while listening, remember there's a nice note for the benefit of the non-technical audience members that I should make. There is a sound that you hear said a lot today, which is tech, and it means two separate things. And it's important. I will talk about the meaning of tech, which has a Greek letter, which is a typesetting system producing traditionally PDF files, and with our software with LaTeXML producing HTML. But the meaning of tech you heard during most of what Mick explained is the meaning of technology. And this could be confusing if you're non-technical. I was actually remembering this is an old point. So stay on your toes about which tech we're mentioning when you hear that sound. Our system converts tech articles into HTML. And the reason we did this is exactly the reason Mick explained. We wanted the rich semantic information, the additional second layer metadata that humans have in their heads. When you read any piece of printed paper, you have it in your mind. This is a heading, this is a table heading. It has this many rows, this many columns. This information needs to be exposed to the machine, to your computer, in order to get all kinds of added benefits, services. And AI is great nowadays, in the last couple of years or 5 years, at finally starting to automatically infer some of that structure the way humans recognize it. But what LaTeX and tech provided originally is enough anchoring. So the human writers, the authors of the documents, provided enough anchoring that we could, even 15 years ago, start producing high quality HTML from your section markup, your math markup, your square roots, what have you. There are all these high-level macros which make writing the document shorter, allowed us to make high-quality HTML. And yeah, so the reason HTML is today so faster moving in accessibility than PDF, there are two fundamental reasons. One is that the community in standardizing is larger. It is an open effort, and it is a very active effort. And second is the design of the standard focuses on capturing structure first, and layout is coming on top, cascading on top, in fact. And you can customize how documents look as a separate layer from how the document's content is structured. And from here, I'll hand it back to Mick for him to continue.
I suppose all I would really add to that is that it's also it's a proven method, just simply based on the vast amount of web content out there. People with disabilities are using web pages all the time, and yeah, there's hit and miss. There's sometimes there are good and bad, but on the whole, generally, HTML is a very, very good success story. Again, because of what was just said about, structure first. And that's always been the case with HTML. So that information has always been there. And yeah, again, it's just about there's such a vast amount of web content out there, which already proves itself to be accessible. There are many different browsers and technologies already and assistive technologies already out there that know how to work with HTML. And look, sadly, that's just not as true. I know there is a great effort in the PDF community to improve this, but we just need to speak on a purely practical level. There have been accessibility standards around HTML going back 20 or more years. WCAG, the Web Accessibility Content Guidelines, have existed for a very long time, and they've been an extremely stringent and thorough explanation of how to make web content, HTML, accessible. So not only is HTML structurally sound and it's structure first, but then also there has been a huge effort to make sure that HTML is used in an accessible way. And so you have a vast amount of tools, browsers, assistive technologies, which know and have been doing this for many years, 20 years, know how to consume this content already. And so it makes sense to jump off this work that already exists. Yeah.
Thanks so much for that. So on that note, around PDF, I wanted to ask Norbert to actually talk to us a little bit about how PDF is being handled in this effort at arXiv. We've rolled out HTML. What's the story with PDF looking ahead? What are your hopes?
Yeah, so many things have been said already of PDF, and all of them are true. Problem is that PDF is a page description language, so it was created to describe a physical print page originally. That also means that many of the additional information that originally is present in the text source, in the LaTeX source, is lost in the conversion and converted to a purely typographical. Put something in a big font in bold on this part of the paper. Now, the PDF Association, so Adobe back then, and now the PDF Association is well aware of this limitation, and already several years ago added accessibility properties in, I think it was version 1.7 of the PDF standard. Unfortunately, and also here everyone is aware of that, the current level of accessibility with PDF, even with the newer versions, is completely insufficient. Don and Mick mentioned this in the personal, so the biggest problem is math formulas are completely destroyed. They are not readable. There is an ongoing work, especially in the last years, very high activity on a new accessibility standard for PDF. This is published already. There are technical problems, like we don't have viewers that actually support the new PDF UA as an accessibility standard. Much worse, we have hardly any tools that generate. But I think at the end, what we want is not like HTML or PDF. It's like we would like to have all of the formats to be as accessible as possible. And I see, for example, in arXiv, so we are working with the PDF Association, and we are trying to push the delivery also of better accessibility for PDFs in the future. So I guess but that is, and this is mentioned by Tony, Mike, and Deyan, this is still quite some time off, because HTML is now at the level where PDF needs still a lot of work to arrive there, mostly to historical reasons and how long energy was put into this. Yeah, so that's the state. For me, it's like I'm very happy to have HTML, and because it is accessible, and I hope that in the future, as arXiv, we can also provide not only as arXiv, it's a general LaTeX tech community that we can provide better accessible PDFs in the future.
Thanks so much for that, Norbert. It's really interesting to hear about both of these formats, and that it's not an either or. We would really like to improve accessibility everywhere, but there are reasons why HTML is the medium that we're focusing on in today's conversation. So we've actually reached our first break time, and would it be okay if we shortened it a little bit? We've had lots of interesting things to say. We have lots more interesting things to say coming up. Could we make it a 3-minute break instead of a 5-minute break? All right, so let's return in just 3 minutes. Got to grab your popcorn fast. See you all soon. Okay, so first we're going to listen to this very simple formula read out loud by the NVDA screenreader from an HTML paper, one of the papers that's on arXiv. And there is a link to this demonstration in the chat if you want to check it out yourself as well. So we'll play this through twice. Screenreader.
The absolute value of phi sub 1 is identical to the fraction with numerator 1 and denominator n sub p. The sum from s equals 1 to n sub p of the absolute value of phi open paren x raised to the open paren s close paren power close paren.
All right, so we're just going to play that through one more time.
The absolute value of phi sub 1 is identical to the fraction with numerator 1 and denominator n sub p. The sum from s equals 1 to n sub p of the absolute value of phi open paren x raised to the open paren s close paren power close paren.
So hopefully you can hear two things from this. One, that it got the formula right, and two, that it's still hard to follow along. It's hard to like hold all of this information in your head when it's reading right through this formula, even though it's a short one. So now we're going to move on to this exact same formula in the PDF, and this just happens to be how this PDF is rendered. Let's see how it does. So keep in mind this is the same formula.
NP P X 1 space bar bar identical to space N P space left paren X left paren S right paren space dot space left paren 2 dot 1 7 right paren 1 space S equals 1.
So same formula. Let's listen to that again. And I know it sounds like garbled nonsense. There is a logic there, and see if you can pick up on what that logic is when we play it through the second time.
NP P X 1 space bar bar identical to space, N, P, space, left paren, X, left paren, S, right paren, space, dot, space, left paren, 2, dot, 1, 7, right paren, 1, space, S, equals, 1.
So I want to pause there and ask some of our experts on the call if they want to share with us what is going on here. What is happening with this formula?
I mean, it's as if it's able to just take, we can see we can hear some of the letters and some of the punctuation, but all the semantic information is completely gone.
Yeah, yeah.
This is a little easier to spot if you can see the bounding boxes moving around, which are very helpful, which show you that it proceeds in a visual layout fashion where it's picking them up top left to bottom right, proceeding left to right, but not being aware of any of the mathematical structure, just finding characters deposited with absolute positions at pixels on the page. The thing that hurts me the most, actually, even though this is all painful, is that we lost the sum entirely. So there's this capital sigma, this massive sigma, which is the biggest thing in the formula. If you're cited and you look at this, it's the thing you see first, and that is entirely gone from the PDF because it is drawn and it's not a character, and it disappears. So yeah, different paradigm.
Yeah. Thanks for that insight, guys. So the last part of this video is back to the formula in HTML, and we're using the NVDA screenreader again to step through it more slowly. And just a shout out to the narrator of this section. This is my assistant, Miranda, who got a really good job on the West Coast, and I miss her very, very much, especially when I hear her narration of this section. So here's Miranda narrating, stepping through this same formula more slowly.
Now I'm going to show how we would move inside the formula by going back and forth.
The absolute value of phi in subscript 1
And then we're going to go right.
out of subscript is identical to.
Now we're going to move on to the fraction. I'm going to press the right arrow key again.
The fraction with numerator 1 and denominator n sub p.
Let's say we want to hear the fraction again. Let's hear it again.
The fraction with numerator 1 and denominator n sub p.
Now
Sum
we're
from S
moving
equals
on.
1 to n sub p of the absolute value of phi open paren x raised to the open paren s close paren power close paren.
Let's hear the last part again.
The absolute value of phi open paren x raised to the open paren s close paren power close paren.
A mathematical. Okay, so I've closed my screen share, but hopefully that gave us all a little bit of a taste as to what it's like to use a screen reader to access mathematical formula to lead us into the next section. And we wanted to start with Tony, who can tell us more specifically about mathematical formula and your experiences. Like, Tony, when we heard that strange garbled PDF math, is that unusual? Is that kind of a normal experience with PDFs? How big of a problem is this really?
Yeah, of course. You can imagine that's actually a huge problem. When you try to read formulas from PDF, as people mentioned, some of the characters are lost completely. Other characters, the semantic information is lost, so they're just the screen reader speaks them in some order, but that's not necessarily correct order mathematically. And even no matter how much you try to explore the formula, you still can't figure out which part is subscript, which part is superscript. So yeah, as you can imagine, trying to figure things out from a PDF paper is very painful.
Yeah.
And yeah, as I mentioned before, there is one solution. There are a couple of OCR. OCR is optical character recognition programs that can try to look at the PDF as an image and try to parse formulas. They can do reasonably good job at parsing them, but again, when it's only 90% accurate, it is also pretty painful trying to figure out what was the true meaning of the formula when superscripts and subscripts are not properly displayed, or when some small mistakes like this happen. So yeah, like once we have papers in HTML format where you can be sure that no characters are lost, and when all the superscripts and subscripts are properly marked, it's infinitely better experience trying to working with papers in HTML format.
Thanks for sharing that. Deyan, we wanted to ask for your perspective from a LaTeXML developer. So you're doing this translation all the time. Why is it different? What does LaTeXML do to get away from that horrible middle example that we saw?
Yeah, it's an excellent topic. First, let me say, as any developer, hearing the phrase, it's only 90% successful, is very scary. LaTeXML over arXiv is less than 90% successful, and we are very aware of this and working on improving it. However, what we can take solace in is that we know when we are not successful. So there is a clear error boundary where we are aware that we're not yet there. So the problem articles are somewhat clear, and the ones that have no problems are somewhat clear, especially for the mathematics. The reason the HTML mathematics sounded as good as it does, well, there are two reasons. First, NVDA is a great software, and it can vocalize well. But the second reason is the underlying representation is a standard called MathML, which is part of HTML5. It's actually a very old invention from 1998 that is still actively worked on. And that standard allows to encode XML trees or HTML trees for a mathematical expression that allows you to navigate through the mathematical structure of the expression. There we have an open research problem that I won't get into, especially for arXiv. I don't know if you have read things at the cutting edge of the frontier of physics and mathematics, but sometimes even to a human expert, it's not obvious what the mathematical structure is of an expression. So there is a step to get to the 100% mark, but to get to the 80% or 90% mark, MathML is a very good option. And sounds quite nice when vocalized. So even in the cases where it's not flawless, you still have a very good grasp of the structure of the expression. That is an accurate grasp of the structure of the expression.
Thanks for sharing that. Nick, we wanted to turn to you next for the NVDA perspective on that demonstration that we just heard. What is happening there from the NVDA side?
Yeah, so there's lots of things that happen all the way from, I guess, sort of, we'll call it the web author or the HTML source, going through all the way to the screen reader. So in general terms, before I talk about math, I'm just talking about HTML. Firstly, want to point out that a screen reader doesn't read the HTML source directly. We don't really do that these days. What generally happens is that the HTML source is loaded into the browser, and it is processed by the browser and is represented as a document tree or a DOM, document object model, which is a very clear standard way of representing a tree of HTML. The idea of the DOM is fully sort of part of the HTML standard in the way that browsers represent it. And that allows, you know, code like JavaScript and stuff to interact with that HTML. It provides clear guidance on how HTML should be visualized or made, you know, that kind of thing, or how the user should be able to interact with it in the browser. However, then there's another step, which is that the browser then makes, I guess, what is called the accessibility tree, which is another representation of the document object model, but more specific and more suitable for accessibility applications like screen readers and other assistive technologies. And so that applies a whole bunch of rules about, you know, say you have an object such as let's say a heading. There are rules about, well, what is the name of that heading? What semantics does it have? What is the level of the heading? Or let's talk about a button. What is the name of the button? Is it pressed or not? Or even better example, a checkbox. You know, what's the name of the checkbox? Is the checkbox checked? Is it half checked? Is it not checked? Those kind of semantic information are exposed in the accessibility tree. And these days, browsers have really good inspection tools for not only seeing what's in the DOM, in the document object model, but nowadays they also have accessibility inspectors as well, which can show you exactly what information is sort of fetched from the DOM and exposed as accessibility. But then from that point, then the browser then exposes that accessibility via specialized accessibility or operating system APIs, essentially allowing assistive technologies running on the system, such as screen readers, to be able to query and fetch information about that document. And various accessibility APIs you may have heard of or might want to look up are things such as Microsoft's UI automation, or the older Microsoft MSAA, or iAccessible 2, which was a joint effort of many different companies to make an accessibility standard. And so then assistive technologies such as screen readers then consume these accessibility APIs, and that is how they see the document. So it's a long path from the source, you know, from the document author or the web author through the document object model in the browser, then to an accessibility model, then to an accessibility API, and then on to the assistive technology like the screen reader. And then, of course, the assistive technology itself has to do a lot of processing as well in terms of the user's particular needs and requirements, in terms of how things are reported, whether it's reported in speech or braille, what certain things are reported, because, you know, one blind person might want a lot of information, one blind person might want a little bit less information because they might move around fast, they might be a little bit more expert or something. If we specifically talk about math, as was pointed out before, this conversion from LaTeX to MathML. MathML is is an XML standard that is handed off to the assistive technology or the screen reader, and we have the ability to parse that MathML and make a sort of a tree structure of it so that we can understand the full semantics and layout of the mathematics, of the mathematical formula. Now, I should say that not all the magic was in here is entirely specific to NVDA or was coded by us at NVDA. There has been some terrific work done by people like Neil Soifer, who originally wrote Math Player and now the open source MathCat software. And this software can be used by NVDA to parse the MathML and provide a really good accessible output of that math. Because it's not just about speaking the math formula in one particular way. There are different standards of how to represent math appropriately in both speech and Braille. And even before us and people like Neil Swiffer and things like that, there have been some really great research into mathematics, which goes back a long way in terms of how best to speak or Braille mathematics. And we're talking, you know, right back to people like Abraham Nemeth and other wonderful trailblazers like that, who have come up with really good ways of non-ambiguous ways of speaking math content. So together, yeah, so NVDA relies on quite a few different apps and libraries and stuff to parse this MathML. Not only can it speak and Braille it, but it also allows the user to be able to navigate the math formula in a tree structure. So not, it was sort of shown in the video, but in a little bit more depth. It does mean that a user is able to actually drill down into particular parts of the mathematical formula. So in that example, there was a fraction. It is possible with NVDA's math support and MathCat to be able to use particular keyboard commands to drill down into that fraction and be able to move within the denominator or within the numerator. And so because it's very hard for anyone or as a blind person to keep so much information of a really large formula in your head. So sometimes it's useful to focus on a particular part of that formula. So it's, again, just the fraction or just the sum or just the bit that's in the brackets. And you can then move, you know, within that part of the tree, and that's extremely powerful for blind people. But yeah, in summary of this, really, there's a great deal of processing that goes on, but none of that processing is possible without the full, rich semantic information of the underlying math formula or HTML. And it's wonderful to see projects like LaTeXML being able to generate this HTML and MathML without losing all the rich semantic information, so that we, as NVDA or other assistive technologies, can go on and do, and can represent it as efficiently and as richly as we can, so that blind people can get their work done.
Thanks so much for that, Mick. That was really fascinating and amazing to hear about the rich ecosystem and the rich history that's led us to this point. So we're going to take another very brief break. Let's make it 3 minutes again, because we have so much that we want to still talk about. And when we come back, we'll get to Q&A. We have some questions that folks sent in advance, and there's some new questions coming in. So let's take a 3-minute break. All right, let's gather back. We're going to start out with some of the questions that came in advance, and there's so many more really amazing questions coming in. We'll get to as many as we can. So one of the questions that came in advance is a tough question. And one of the questions that people in software dread most. So I'm going to start with Norbert. Norbert, we know that not all papers on arXiv have HTML yet. How long is it going to be? Sorry, super tough question for you.
That's a very good question. It's probably, it's mostly a question of how much money we can throw at the conversion, because it takes time, and that is computing time, and that costs us money. And since arXiv works on donation basis and grant basis, we don't have infinite resources. I don't want to promise anything how long it will take, because it's hard. But to be very clear, in the meantime, there are 5 project has, Deyan can correct me, HTML renderings available for the whole corpus, as far as I remember. And yeah, so that for the meantime can be used.
Yeah, Deyan, could you follow up on that and share a little more about what some of the challenges are there?
So the preview project, it's an arXiv lab from 2022 called R5. That is AR, the number 5, and then IV.org or .labs.archive.org. That preview site has as much of arXiv as LaTeXML can manage to convert. It was graciously given hardware by the Quark research group in Germany, my PhD research group. And that is 75% of arXiv error-free. And multiply that by 2.2 million documents. And it's a pretty substantial chunk of arXiv error-free. And the LaTeXML team is interested in getting it to, well, at least 90%, because we heard that is the least acceptable number, and hopefully much beyond 90% later on.
Great, thank you so much for that. I wanted to field the next question to Tony. Could you share with us, Tony, have the HTML papers on arXiv made a difference for you?
That's a good question. I can feel the difference already, even though this HTML papers program has been running for what, less than a year, I think, right?
Yeah.
But yeah, I can give an example. Recently, there was a paper in machine learning that made a lot of noise. It's called Kolmogorov-Arnold networks, or CANs. And it was published on arXiv, and this paper is available in HTML. So I was very excited about that, because now I don't have to struggle with PDF, right, to read it. I think another option would be to try to find this paper in LaTeX format, which is it's good to have it in LaTeX format, but I would still think that the best one is HTML, because it presents the formulas in the best format possible currently. So yeah, I didn't read the whole paper, but I read about like sort of maybe 1/2 or 1/3 of it, and it really made a lot of difference, because now I don't have to be scared of of PDFs anymore in order to stay up to date in research in my area.
Thank you so much for sharing that.
Yeah.
This is a question for Mick, and it asks, for academic papers that don't have HTML versions, do you recommend any tools to convert these papers to HTML or to a more accessible format? I guess, do you have a tooling path that you would recommend?
I'm probably not the best person to answer that. I work, I think in my area, I work more when they're already converted. I mean, look, I did have to use LaTeX and PDF and things like that in my university days, but that was a very, very long time ago. I mean, look, blind people with disabilities are very good at finding what they need in order to get the job done. However, that doesn't necessarily make it right either, as in much as this is removing the burden for people to have to jump through so many hoops to get something done. It's amazing how much a blind person has to do, even just say in a university context, so much more than their sighted counterpart, just to pass their subject. They have to constantly working with the lecturer to get things in an electronic format, or perhaps telling the lecturer how they can improve that. They have to be so independent and organize so much more. And so any barriers we can remove there, any extra burdens, greatly helps people with disabilities be more efficient, more functional, and contribute in a much more meaningful way to society. So, you know, I think really like there's some wonderful, amazing tools we see in LaTeXML and what arXiv is doing. And so I just watch this space and I think it's going to be, you know, it's already looking great, and I think it's going to be a really, really good future, you know. So
on that note of working to remove as many barriers as possible, this question came in that I'd love to just go around and ask each person. They are asking, are there any important don'ts regarding writing math in LaTeX for a good conversion? And just want to maybe go around in a circle and see what folks have picked up about writing math the right way. If there's any advice that you would give, could we start with you, Norbert? How do you write math the right way for accessibility?
Probably not the way I am writing math, because it's bad. Yeah, so I guess so the best way is not to try to reinvent the wheel, but try to reuse commands from large and supported math package like AMAS math. The reason is that for the LaTeXML, for each package, it needs to get support, and that doesn't work if you just code your own representation of formulas. So the problem with tech is that you can't do everything on a very low level and just move every single piece by points to get a perfect layout. This is nice for a visual representation, but it's very hard to translate into LaTeXML or in MathML. And so I think the best recommendation is don't try to write and reinvent the wheel and write everything yourself. Use macros and macros and macro packages that have support the LaTeXML. I think that is the best way to go forward.
Yeah, thank you for that.
May I follow up with an example? So I'm notorious for having so many examples that I can probably speak an entire day just giving variety, especially from arXiv, funny examples. And while Norbert was talking, one completely new one came to mind that I don't think I've said before. There is a very famous way to end the proof in mathematics, which is the QED symbol. It is a small black box. There is a famous macro for that symbol, which is \QED. Please use that macro. LaTeXML supports that macro. We can capture it and provide nice HTML for it. What you should not do, and I'll give two examples for this symbol. One is to make a small phantom box of the right size and then give it a left border, a right border, a top border, and a bottom border, which has happened in arXiv. A second way of doing this is to take the TXZ package and draw 4 lines at 90-degree angles that touch and make this little square that you drew with your custom TXZ code, your own personal QED macro, which may be 0.2 millimeters, either longer or shorter than the usual one, because you want to have perfection. And every time you do this, you will sacrifice accessibility by default. But here's, I always have a positive peace pledge to the people who really want to do this. If you insist to have the perfect visual construct, please spend the extra time to come to the LaTeXML side and write a small support macro in LaTeXML that will provide perfect accessibility for your visual construct. So if you just do a little bit extra work, you can have your cake and eat it too. But otherwise, please abstain from these tricks because they will sacrifice accessibility by default.
I would like to jump here because it answers a few questions that were in the QA, what Deyan just said. Yes, it is possible to provide LaTeXML support if you write your own macros or your own extensions. This is documented in the LaTeXML documentation, and yeah. Because they have a few questions in the QA whether this is possible, and yes, it is. So.
Yeah, also I would like to echo back on this QED symbol. I guess I would like to generalize this in order to make things accessible, use standard ways. As as opposed to coming up with your own fancy way to draw a symbol. This advice tends to be true in general for many aspects of accessibility. For example, like on the web, same thing applies to. Yeah, so using the chances that standard tools are going to work with screenreader are much higher. And yeah, I guess try to abstain from non-standard packages, maybe from non-standard characters. Yeah, for example, I've heard that when mathematicians run out of Greek letters to use, sometimes they use Hebrew letters. And to be honest, I'm not even sure if NVDA or any other screenreader can read Hebrew letters, but should be fine with the Greek letters. Yeah, so that would be my 2 cents. Is just try to use standard tools, and the more standard the tools, the more likely they are to be well supported in terms of accessibility.
Mick, do you have anything to add to this list of advice? On the
I think it's really, I mean, people have sort of hinted at this, but I mean, I think it really just is very simply think structurally, don't think visually. That's what it comes down to. And that's going to help people with disabilities. It's also going to help, as I touched on right at the beginning, about, you know, transforming to other formats or interacting with things with other tools, you know, like AI processing or voice input or whatever. I mean, I can just think of a really, you know, simple example, nothing to do with math really, but, you know, some people in the past, I've received, you know, text messages from family members who, you know, just got a computer or something, and I can't work out what they're typing about because it's like L love something or other. And I've realized what they've done is they've used a lowercase L instead of an uppercase I or something on the keyboard because apparently it looks, you know, similar or whatever in their font. That's not good enough. You need to think structurally, not visually, because screen readers do identify the difference between those things, not visually, but structurally, but, you know, semantically. And as I say, it's not just going to be a problem for screen readers, it's going to be a problem for search indexing and, you know, search engines and AI processing and voice input, etc. So structure over visual all the time.
Great, thank you for that. There's a number of questions coming in that are asking about templates or ways that people can more easily write for posting on arXiv in a way that will maybe guarantee is too strong a word, but are there templates out there? Are there any shortcuts that you could recommend in particular, Deyan, for authors who are looking for more guidance?
So this is important to address in the real world, where we have an ecosystem of participants in this process of academic publishing. There is a very, very important player that provides templates to scientists, and that is the submission venues, the journals and conferences where scientists submit, or even the publishing houses where they submit their textbooks. And in a way, luckily for us, they're also very invested in this new question of accessibility by default, because it has become a legal imperative for most of them to address the question. So I would say coordinate with people who develop tools. If it's something specific of a construct, people like me who develop LaTeXML, but also with your submission partners where you're going to provide your final document. So if you're just submitting to arXiv, talk to the arXiv team. If you're submitting to a journal, talk to the journal to improve their templates, to ensure that at least their template document is with high quality accessibility, and then you can work within their framework. I don't think it's LaTeXML's job to provide templates by default, because we are concerned with the infrastructure there underneath the template. And there are also hundreds, if not thousands, of ways to create a good academic template for a variety of documents. So I think really the players, we should expand the team. Every single player that has an interest should participate, and we should get a wide spectrum of accessible templates available for everybody.
Yeah, yeah. On that note of expanding the team, one of the concepts that came up as we were planning this session is the need to distribute the load. And I wanted to make sure we have time for everybody to share their thoughts on what's next. What do you think needs to happen next? What do you really hope happens in the next couple of years in this effort to make research more and more accessible? And maybe we could do a go around, just broadly, what comes to mind for you? What's on your wish list? And maybe we could start with Mick.
I suppose the thing that comes to mind for me first is not just about being able to read this information, but being able to efficiently write this information too, in terms of, this is not so much necessarily a research writing academic papers as such, but I mean, it can apply here too, but also in schools and universities, being able to efficiently write mathematics in, say, for instance, in Braille or something like that. I think that the standards, even though as much as, you know, we've made a lot of success with these standards, I think there still are ways to go in terms of MathML, etc., and the tools around it to allow for not just output, but also input. That's certainly something that's asked for a lot. But also, I think really a more general ask, I think, is really just that if we can, I've been around a while and I've seen so many, you know, it's been wonderful to see mathematics suddenly take off in terms of things like Math Player and processing of MathML in screen readers since about 2014 or so. And there are so many different wonderful ideas. There are so many accessible math calculators or whatever, or other prototypes or math editors are floating around. But it seems that in many cases, people are going off in their own little silos. They have wonderful ideas, but they're not necessarily working together. And that's really not very useful for the industry as a whole. It's amazing how many times I have calls in my capacity at NVDA, have calls with people from various organizations who talk about the wonderful things they're doing in maths or whatever, but they don't understand that, you know, perhaps that it's already been done by another person or by another organization, or that they come to us with a lot of complaints and bugs because they have a misunderstanding around what's actually available. And so I really want to stress that it's important for us all to get together in forums like this and other things. There were some successful, there was certainly one successful forum held in 2018 by the National Science Foundation in the US, and brought a lot of accessible math people together. And we had some wonderful discussions about how to forward things like, you know, LaTeX to MathML. I can't remember exactly what was talked about, but, you know, and then furthering the MathML specification and looking at all the wonderful things that were going on and different prototypes and such. But yeah, it's about standardizing this stuff. It's about all talking together, and it's about moving forward as one rather than being all fragmented. I think that's the biggest problem here at the moment.
So I'm hearing a direct call for more collaboration and standardization. Yeah, thank you so much for that. Well, I want to ask Norbert the same question. Norbert, what would be on your wish list? What needs to happen next to make research more accessible?
Yeah, I would answer with two things. One that Mick already mentioned is the walled gardens. Like, we live in a world where the commercial economic interests of companies often stands in front of actual development. I could name several companies that have this, well, most of them, and despite being in the accessibility space. So that is probably the hardest part, because we cannot really change how companies work. Standardization is good and the way to move forward here. On the other side, I would So HTML is already very good, as we heard from many people with respect to accessibility. Of course, there are things that can be improved. As I mentioned before, also, I would like to move the PDF also into a space that is much more accessible. I don't see this happening in the next year, but I see that in the next few years, we can automatically produce accessible PDFs. And with, I mean, accessible PDFs, I mean that are actually usable accessible PDFs, not what the current standard is, so the old standard. Because at the end, we have seen that PDF is still till today one of the main way how people communicate scientific research in at least in some areas. And so having those PDFs more accessible in addition to the HTML and in addition to other formats is for me what I would like to see in, let's say, 3 to 5 years' time.
Excellent, thank you. Tony, what about you? What's on your wish list? What needs to happen?
Yeah, I wish that I wish that other, for example, conferences in my field, well, not necessarily my field, I wish that conferences adopt this strategy as well of publishing papers in accessible format. Because the reality these days is that some papers when some papers appear in conferences, some authors submit a copy to arXiv, some don't. So it's kind of hit and miss, right? But I wish that it's going to be a requirement for machine learning conferences and hopefully conferences in other fields as well to require, not necessarily require, to those conferences, they accept submissions in LaTeX format. So I hope that they can adapt the tools that arXiv developed so that they can also publish papers in HTML. So in my understanding, I reached out to those conferences like 5 years ago, and in general, their attitude was positive to accessibility, but they complained that there was no tools readily available for that. So now with arXiv making so much progress on this accessibility tooling, I can point them and say, look, arXiv has done it already, so you can just do whatever arXiv is doing. So I'm very excited about that.
Yeah, thanks for mentioning that. And I'll just add a little note in here that we have been having a number of conversations with different publishers who are interested, and we're connecting them with the LaTeXML team just to help share that knowledge of what arXiv did. It can be done. It's not necessarily easy, but it's possible. And happy to share with additional publishers or conferences everything that we've learned so far, if that's helpful. And on that note, Deyan, how about you? What do you think needs to happen? What do you want to see happen?
Yeah, I get to make the high-level scholarly remark because I'm speaking last, so that's all that's left for me. I would say, why not both? So standardization is very important, but innovation is also very important. And I think we should have both. The reason I read arXiv and have 40 open tabs on my screen is that I'm hoping 1 or 2 or 3 of those tabs will hold the methods I need to stop wasting manual labor and have a solution that automates something for me, or an insight that allows me to compress and solve a problem space that is really difficult and has no obvious choices, or just a nice approach that allows me to reach further than I was going to reach before. So this innovation aspect always has to come first. Accessibility has open research conferences, and I think it's active, and people are quite curious to get further. If anything, it's underfunded. I'm going to agree with this, and I think it will become important to sustain, maybe on the back of AI, but maybe not necessarily also on the back of the new legal changes. Just sustain enough innovation and accessibility that at the back end of that process, we receive all the good ideas and standardize them. And then the tools come and make everyone the most productive possible experience. So yeah, I think I'm just going to broaden the tent as far as I can and say, why not both innovators and standardizers can all productively contribute to the space, and that would be amazing.
That's a beautiful thought to end on. We are at time, folks. I'll just add again that there is a discussion board on the webpage for this conference session, this forum session. That's a great place to keep conversations going. And there are so many questions that we didn't get to. And what I'm going to do is gather those. I'll run those by the panelists, and we can post any responses that come in to that discussion board as well. So keep an eye on that, hopefully for more answers to your wonderful questions in the near-ish future. And just want to say on behalf of arXiv, thank you so much for everyone who participated in this panel, and the volunteers that you don't see in the background, and everyone who came together to help make this happen. This was wonderful. Thank you so much.
Thank you.
Thanks, everyone.
Thank you.
And thank you, Shamsi, for organizing.
Yes, thank you.
Yeah.
It was a pleasure.
Good night and good morning and good afternoon, depending on your time zone.
Yeah, thank you.
Bye all.
Bye-bye.
Bye.
Bye.